Are you able to hear me? Somebody can respond. Are you able to hear me?
Yes, sir. Yes, sir.
302.
Yes, sir.
Are you able to hear me? Right?
Yes, sir.
But I'm not able to hear you. Just I'll see the sound settings. 1 minute. No, it is okay. Okay, now you respond. I think now it is audible to me also.
Yes, sir. It is audible, sir.
Okay, right. So, okay. So, we'll see the eccentric loading cases. We are discussing about the bolted or threaded joints. So, in that, we already seen when there is a load due to initial tightening as well as load due to external load, how we can compute the stress value or how we can design the bolt. Design in the sense how we can find the size of the bolt required. So now we'll consider eccentric loading. So that means when a bolted joint which is subjected to eccentric loading. So in that, the first case is when the eccentric load is in the plane of the joint. So because of that, what are various stresses which are induced in the bolted bolts, and based on that we are going to design the joint. So this one is quite similar to the riveted joint when it is subjected to eccentric loading. Both are same. Only thing is here we are using bolts, there we are using only rivets. That is the only difference, except that everything, the procedure and the type of stresses induced, everything is similar. So even the equations are also similar to the riveted joints. Okay, so anyway, we'll see that, and we'll first see how we can analyze this one, and also we'll take up one numerical problem on this and how we can solve the numerical problem. We'll discuss these things today's class. So first of all, here, so you can see that in this figure you have a bracket which is connected to some plate or maybe some ball through some bolts here. So in this case, there are four bolts are there. 1, 2, 3, 4. So and this bracket is subjected to some force P at this location. So now, why I'll call this one as a eccentric load, because here, if I find the center of gravity of these bolted connections or these bolts, center of gravity of these 4 bolts. So here in our joint we have only 4 bolts. Maybe in some other joint you may have another number of bolts. That may be 6 or 3 or maybe 8 or 10, anything like that. So it doesn't matter what are the number of bolts. So whatever may be the number of bolts, the procedure remains same. Whether number of bolts are 4 or 2 or 6 or maybe 8, for that matter any number, the procedure will remain same. So you have your bolts are arranged somewhere here, so like this. So if you want to have additional bolts, you may have something like this also, but the load is applied away from the center of gravity of this bolt system. So here this is our bolted connection here. So always this applied load is away from the center of gravity of this bolted system. So the bolted center of gravity, I will find the center of gravity here. So just like in case of riveted joints, what we did there, we'll follow the same thing here. So center of gravity means how we can find it is you choose some reference point as your origin. Then let us say this is my reference position. So I'll take this is x axis and I'll take this one as y axis. Then for each bolt I need to identify what is the x coordinate, what is the y coordinate, and what is the x coordinate and y coordinate. Of course, it is a plane problem. You need to find out z coordinate is not required. You have to find out what is x and what is y. So based on this, so if I know the distance, in all the problems they will give you these distances. If I know this distance, I can easily find what is the x coordinate for this and for this also, provided if they have given this distance. So since it is a explanation of the procedure how we can solve the problem, he has not given the numerical values, but still we know in all the problems they'll give those distances. Now once I know these distances, we can use the formula x bar is nothing but, that is, x bar is nothing but the coordinate or the center coordinate of the center of gravity, which is given by sigma ai into xi divided by sigma xi. So this is the formula where I is 1 to n, 1 comma 2 comma up to n, where n is the number of bolts here. So but here what we'll do is we'll assume that all the bolts are having same cross-sectional area, means the diameter of all the bolts is same. So that is assumption only. Basically, it is an assumption. So it need not be always the same case. But to simplify the analysis, what we'll do is we'll assume that each bolt is having same diameter d. So nominal diameter is same for each bolt. So in that case, what happens here is, so this sigma ai will become now n number of, or else, okay, so you can take that one as outside of that. Okay, here it is, the formula is wrong. Sorry, here sigma ai xi divided by sigma ai, that is the formula for x bar. So here if I take diameter is same, means for each bolt the area is going to be only a. So that means your a1 is a, a2 a3 is also equal to a, and a4 is also equal to a. That means the area of the each bolt is same. All the bolts are having same cross-sectional area. So in that case, if I take that, here since area is constant, if I can cancel out this sigma ai by ai, then finally what you'll get is your x bar is nothing but sigma xi divided by n, where n is number of bolts. So that means you need to identify what is the x coordinate for each bolt, then sum of all those x coordinates and divide that sum of the x coordinates divided by the number of bolts, will get your x bar. Similarly, I can calculate y bar also. Y bar is nothing but sigma yi. So that is summation of y coordinate of each bolt divided by number of bolts, you will get the y bar. So this is the procedure what we follow in case of riveted joints also. So the same thing will follow here also. So that means first what you have to do is you need to identify what is the center of gravity of the given bolted connection. So here for this it is since and also sometimes instead of using these formulas also directly you can identify the center of gravity based on symmetry. So symmetry in the sense, if I draw a line, vertical line, let us say here, so this bolt, these two bolts are say at same distance from this point. Even these two bolts are also at the same distance. So this distance and this distance, this is same. So then I can call it as a symmetry. So that means symmetry is nothing but the mirror image of one side of the other. So that means if I take this side is mirror image of this side, then I can call it as a symmetry. Similarly, if I draw the horizontal line here, so this side is same as this side. So this side is mirror image of this one. So like that, if you have a symmetry in the system, if you have a symmetry about both the axes, that is, this is the horizontal axis, so I can call it as symmetry about horizontal axis. If top and bottom are mirror image of one of the other, I can call it as it is symmetric about the horizontal axis. If I say left and right, so okay, this is right and this is right, left and right portions are mirror image of one or the other, then I can call it as it is symmetric about the vertical axis. Suppose if it has a symmetric about the horizontal axis as well as vertical axis, the intersection of the horizontal and vertical axis is going to be the center of gravity. Straight away you can identify like that also. Instead of using that formula, that is x bar is equal to sigma xi by n, and sigma y bar is sigma yi by n. So if there is a symmetry, straight away you can identify that just by identifying what is the intersection point of two symmetric axes, you will get the center of gravity. Okay, so that we already know, we already done in case of riveted joints also. So anyway, so we are discussing that again also, right? So now once I identify the center of gravity, now if this load line in the sense line of action of this applied force is away from the center of gravity, so then I can call it as eccentric load, and this distance will take it as eccentricity denoted by E, letter E. So then we can say this is an eccentric load. So then again, whether that eccentric load is creating a shear stress or bending stress, that is a different issue. First, as long as if you have a bolted connection, so if you identify the center of gravity of that bolted connection, if the load line, this is the line, if it is not passing through the center of gravity, that means suppose if you apply the force here, I cannot call it as a eccentric load because the load line or the point of action of this line is passing through the centroid. I cannot call this one as a eccentric load. So it should have some offset distance or eccentric distance. Then only I can call it as a eccentrical load. So therefore, I call this joint as an eccentrically loaded joint. So now, if you take this particular case, here the load line is something like this. It is your plane of bolts is also same thing like this. This is our plane of just like I told. If you choose this one as x-axis and this one as y-axis, maybe it need not be this point. Any point you can take as your reference. This point also you can take it. So here your load is acting along y direction. So that means your plane of the bolts is xy plane and the load is y direction, means both are in the same plane. So this is y direction, means this load is also in xy plane. So therefore I can call this one as the load which is acting in the plane of bolts. So now if the load is like this, that means if you apply the load like this will induce you a shear stress. So what is the shear stress? Whether there is only one single shear or there may be two shear stresses. If there are the cases, how you can find the magnitude of those stresses, we'll see now. So now because of this load, I think we already discussed in case of riveted joints. So now if in order to find the effect of this force at this location, then what you need to do is you need to transfer this force to this. That means from the applied point to the, we need to transfer this load to the center of gravity. So now if I transfer this load to center of gravity, here its effect is going to be a force whose magnitude is P and acting in the same direction. In addition to that force, it will create a moment, so which is going to be M, and that magnitude of that moment is given by P multiplied by E. P multiplied by E. So here he has shown this is the eccentric E. So unload is P. So P into E is going to be the moment. So now this is the effect. This is the effect of this load force P, which is transferred from this point, this line of action to center of gravity. So now we want to see what is the effect of this force P and what is the effect of this moment M. So now if you are able to find that, then you can easily identify what is the size of the bolts also. So now, okay, I'll show you that. Anyway, I have pictures that this is eccentric force can be considered as an equivalent to an imaginary force at the center of gravity and a moment P into E about the same point. So that's what I already told to you. So the effect of transferring this force from this load line to the center of gravity is a direct force of magnitude P in the same direction. That is also important. Direction is also important here. Don't change the direction. If you change the direction, obviously you will get a wrong values or wrong results. Then the moment is also, so now if you take moment about this point G, the moment of this force is nothing but P into E. So in which direction it is in clockwise direction. So here you need to consider that one is also clockwise only. Yeah. So now because of this, we know this is a direct shear force. So and we'll call it as a primary shear force. And because of this movement, so there is a secondary shear force in the bolts. So now if I are able to find out that the direct shear force and secondary shear force, not only their magnitude, we need to identify what is their direction also, because these are the vectors. So to find out the resultant force, so then you can easily find out. You have two forces. Let us say one force is acting something like this, the other one is something like this. So the angle is, if the angle is 90 degrees, I can easily find out what is the resultant of these two forces. Or if not, the angle is 90 degrees, let us say two forces are something like this. If I know this included angle, let us say it is theta, if this is P1 and if this is P2, I can find the resultant force of this P1, P2 also. So that means here what you need to do is, you need to identify or you need to find out what is the magnitude of the primary shear force and what is the magnitude of the secondary shear force. So for that, so okay, this is the free body diagram of these bolts. So what you can see it here. So This is our center of gravity where the force is applied, whose magnitude is P, and a moment of P into E is applied here. So because of that, so now if I consider only the primary force here, since the force is acting vertically downward, the reaction of the bolts is going to be vertically upward. So therefore, we'll denote that one as a primary force, or the reaction of the bolt or the load on the bolt is nothing but in the opposite direction to this applied force. So that's why here it is shown here. For first bolt it is P1 dash, for second bolt it is P2 dash, and for third bolt it is P3 dash, and for fourth bolt it is P4 dash. So single dash is used for the primary shear load, and double dash you can see it here also, P1 double dash, P2 double dash, P3 double dash, and P4 double dash. These double dash symbol or notation is used for the secondary shear force. So now, first we already seen that. So that is because of this force there is a primary shear force, and those primary shear forces are denoted as P1 dash, P2 dash, P3 dash, and P4 dash in respective bolts 1, 2, 3, 4. Here you have 4, up to you have only P4 dash. If you have more than 4 or less than 4, accordingly you need to consider the primary force. Then what is the magnitude of this P1 dash and P2 dash, P3 dash and P4 dash? Since we are assuming that all these bolts are having uniform cross section, that means the diameter is same. So the load is acting at the center of gravity of this bolt system. So therefore the load on each bolt is going to be same, because it is acting at the center of gravity of this bolted connections are for all these bolts. So then the load taken by, because this point of application of load is at equidistances for all these bolts. So therefore the load acting on each bolt it is going to be same. So therefore the magnitude of your P1 dash, P2 dash and P3 dash, P4 dash is same. That means your P1 dash equal to P2 dash equal to P3 dash equal to P4 dash and so on so. So, and what is the magnitude? So since I already told that the load is equal, so therefore the total, whatever total load you have, which is P, then the load on each bolt it is going to be P1 dash equal to P by number of bolts. So like that. So from that we'll get the primary force, primary shear force. Imaginary force P at the center of gravity result in primary shear forces given by the following equation. That is the magnitude of P1 dash, P2 dash and P3 dash and P4 dash and so on are equal, and it is given by applied force P divided by the number of bolts. So here in this case if you have 4 you need to consider 4. If you have 3 bolts you have to consider 3, like that. Whatever may be the number of bolts, you can consider the number of bolts and you can find the primary shear force in each bolt. Once I calculate the primary shear force, then I want to find out what is the effect of this movement. So, and we know here, since the bolt axis, so this movement is acting in which direction? Anybody can answer? So what is the direction of this movement? Whether it is along about the axis of the bolts or in the direction perpendicular to the axis of the bolts. So this is, let us say, x-axis. If I say this is x-axis, this is y-axis. So now this is your distance. So your load line is in which direction? What is responding? Whether the people are there or not? Okay. Yeah, still there. So why nobody is responding then? There are roll number 7.
Sir.
Tell me what is the direction of movement here? Our load is, let us say, if I take this one as a y-axis, this load is acting along y-axis. This is x-axis and this is y-axis. Your load is in the negative y direction and this offset distance is along x-axis. So what is the component of movement you are going to get about x-axis or about y-axis or about z-axis? Due to this load, ఈ లోడ్ వల్ల మీకు మూమెంట్ ఏ యాక్సిస్ తో వస్తుందా, ఎక్స్ యాక్సిస్ లో వస్తుందా, వై యాక్సిస్ తో వస్తుందా, జెడ్ యాక్సిస్ తో వస్తుందా? ఇది నేను ఎక్స్ యాక్సిస్ అనుకున్నా, ఇది వై యాక్సిస్ అనుకున్నా. నీ లోడ్ వై యాక్సిస్ లో ఉంది. ఈ అప్సైడ్ డిస్టెన్స్, లోడ్ ఇంటూ డిస్టెన్స్ ఏనా నీకు మూమెంట్? లోడ్ ఇంటూ పర్పెండిక్యులర్ డిస్టెన్స్ ఆర్ ఫోర్స్ ఇంటూ పర్పెండిక్యులర్ డిస్టెన్స్ ఇస్ గోయింగ్ టు బి ద మూమెంట్. అంతేనా?
అవును సార్.
సో దెన్ దిస్ ఈజ్ ఈ లోడ్ ఏ డైరెక్షన్ లో ఉంది?
డౌన్వర్డ్.
వై డైరెక్షన్.
వై డైరెక్షన్. ఇది డిస్టెన్స్
ఎక్స్ సార్.
డిస్టెన్స్ ఎక్స్ డైరెక్షన్ లో ఉంది, లోడ్ వై డైరెక్షన్ లో ఉంది. సో ఇప్పుడు క్రియేట్ ఏ మూమెంట్ ఏ అబౌట్ విచ్ యాక్సిస్ ఇట్ ఈస్ గోయింగ్ టు క్రియేట్ మూమెంట్? ఏ యాక్సిస్ తో మూమెంట్ వస్తుందా? ఎక్స్ యాక్సిస్ తో వస్తుందా?
ఎక్స్ లో సార్.
యూజ్లెస్ వల్ల ఎక్స్ లో ఎందుకు వస్తుందా? ఎక్కడ నిద్రపోతున్నారు నువ్వు? అయిపోయింది, కోర్స్ అంతా అయిపోయింది. 1 సాల్వ్ చేసి ఉంటాయి ఇట్లాంటి ప్రాబ్లమ్స్. ఎసెంట్రిక్ లోడ్ మళ్ళీ ఎక్స్ లో వస్తుందని చెబుతుంది. ఎక్స్ లో ఎందుకు వస్తుందిరా? So this is what you can say I this is J.
Sir, why sir x కాదు సార్.
నిద్రపో, అక్కడ క్లాస్ లో కూర్చో, ల్యాప్టాప్ ఎదురుగా పెట్టుకుని నిద్రపోరా. నోటికి వచ్చింది చెప్తా ఉంటా. ఎక్స్ కాదంటే వై, వై కాదంటే జెడ్, జెడ్ కాదంటే ఇంకోటి. ఎందుకు ఉపయోగం ఉంది దానివల్ల? ఐజేకే. సో ఈ మూడు వెక్టార్లు పర్పెండిక్యులర్ గా ఉన్నాయి మూడింటికి. సో ఐ క్రాస్ జే అంటే ఏమొస్తుంది చెప్పు నాకు? అట్లానే జే క్రాస్ కే అంటే ఏమొస్తుంది? చదువుకున్నావు అసలు? ఏంటి కొత్త కనపడుతున్నాయి ఇవన్నీ నీకు?
ఐ క్రాస్ జే కే సార్. ఐ క్రాస్ జే కే.
ఐ క్రాస్ జే కే అంటే ఏంటిది?
కే క్రాస్ జే క్రాస్ కే ఐ సార్.
జే క్రాస్ కే ఐ అన్నావు, బాగానే ఉంది. ఏంటిది ఐ? ఏంటి ఈ క్రాస్ అంటే ఏంటి? ముందు ఫస్ట్ చెప్పు. వెక్టార్ కి 2 ప్రొడక్ట్లు ఉంటాయి, స్కాలార్ ప్రొడక్ట్ అని, క్రాస్ ప్రొడక్ట్ అని. గుర్తుందా?
3 డైమెన్షనల్ అవి కోఆర్డినేట్స్ సార్, యూనిట్ కోఆర్డినేట్స్ వెక్టార్స్ అవి. క్రాస్ మల్టిపుల్ అది వెక్టార్ క్రాస్ ప్రొడక్ట్ సార్ అవి.
దిస్ ఈజ్ వెక్టార్ క్రాస్ ప్రొడక్ట్. వెక్టార్ అట్లనే డాట్ ప్రొడక్ట్ ఉంది, క్రాస్ ప్రొడక్ట్ ఉంది.
అవును సార్, 2 ఉంటాయి.
సో ఐ జే 2 వెక్టార్లు ఎట్లా ఉన్నాయి చెప్పు? వాట్ ఈస్ ద యాంగిల్ బిట్వీన్ ఐ అండ్ జే? ఐకి జేకి యాంగిల్ ఎంత ఉంటుందిరా?
90 సార్. 90 పర్పెండిక్యులర్ ఉంటాయి 2.
అట్లానే ఐకి కేకి ఈ 3 మ్యూచువల్లీ పర్పెండిక్యులరా కాదా?
3 పర్పెండిక్యులర్ ఉంటాయి సార్. 3 యాక్సిస్ మీద ఉంటాయి.
అంతే కదా. ఇప్పుడు ఏ యాక్సిస్, ఏ 2 యాక్సిస్ లో తీసుకున్నాడో వాటి మధ్య యాంగిల్ 90 degrees ఏనా?
90 degrees ఉంటుంది సార్. అవును సార్.
అంతే. ఇప్పుడు ఏంటి? ఇప్పుడు ఐ క్రాస్ జే తీసుకుంటే నీకు కే వచ్చింది, అంతేనా?
అవును సార్.
ఫార్ములానే కదా?
అవును సార్.
అంటే ఏంటి? ఇక్కడ నీకు ఈ ఫోర్స్ వెక్టారా కాదా?
వెక్టారే సార్.
ఫోర్స్ ఈజ్ ఏ వెక్టార్. సో అట్లానే ఇది డిస్ప్లేస్మెంట్ వెక్టారా కాదా?
సార్.
డిస్ప్లేస్మెంట్ ఆల్సో కాంపోనెంట్, ఎక్స్ కాంపోనెంట్, వై కాంపోనెంట్ ఉంటుంది.
వై కాంపోనెంట్ వెక్టారే సార్.
ఇప్పుడు నీకు ఉంది ఏంటి ఇక్కడ? ఇదో వై అనుకో. వై ఏంటి? వై అనుకుంటే జే అనుకో, అంతేనా?
అవును సార్.
ఇది ఎక్స్ డైరెక్షన్ అంటే ఐ అనుకో. ఈ రెండింటికి క్రాస్ ప్రోడక్ట్ తీసుకుంటే ఏమవుతుందా నీకు?
అంతే సార్. సార్ మూడోది
ఏంటది? ఎట్లా ఉంటుంది
అది? వై యాక్సిస్ ఉంటుంది సార్.
మళ్ళా వై యాక్సిస్ అంటే వేరా నువ్వు? సో ఇప్పుడు నీకు ఫోర్స్ ఇది డిస్ప్లేస్మెంట్ ఎక్స్ లో ఉందిరా, అంతేనా? ఫోర్స్ వై లో ఉందిరా.
ఇప్పుడు జెడ్ యాక్సిస్ వస్తుంది సార్. నాకు మీ ప్రెజెంటేషన్ రావట్లేదు.
నువ్వు కబుర్లు చెప్పు నాకు.
నిజంగా నాకు మీ ప్రెజెంటేషన్ రావట్లేదు.
ఎందుకు రాదు నా ప్రెజెంటేషన్? నీకు ఒకటికి ఎందుకు రాదు?
నేను ప్రెజెంట్ చేస్తా సార్, కావాలండి నా స్క్రీన్ చూడండి మీరు.
ఏడ్చేలే కానీ చూడు. సో దెన్ ఇట్ ఈస్ గోయింగ్ టు బి అబౌట్ జెడ్ యాక్సిస్. బండ గుర్తు పెట్టుకో ఒకటి. ఇక్కడ ఎక్స్ వై ఉంటే ఆబ్వియస్ గా మూడోది వచ్చేసి జెడ్. అదే కదా, ఐ క్రాస్ జే అంటే కే, జే క్రాస్ కే అంటే ఐ. అట్లానే ఇంకోటి ఏంటి,
కే క్రాస్ ఐ ఈక్వల్ టు జే. కే ఐ జే సార్, కే కి ఐ కి జే సార్.
ఐ క్రాస్ కే అంటే
ఐ క్రాస్ కే జే సార్, మైనస్ జే.
ఏదైనా టూ వెక్టార్స్ కి నువ్వు క్రాస్ ప్రోడక్ట్ తీసుకుంటే దాని రిజల్టింగ్
వెక్టార్
వెక్టార్. ఇక్కడ గుర్తుపెట్టుకోవాల్సింది ఏంటి, ఇఫ్ యు టేక్ ఏ క్రాస్ ప్రోడక్ట్ ఆఫ్ టూ వెక్టార్స్, ద రిజల్టింగ్ ఈజ్ ఆల్సో ఏ వెక్టార్. అట్లా కాకుండా నువ్వు ఐ డాట్ జే తీసుకున్నావు అనుకో, ఏమొస్తుంది నీకు?
ఐ కి జే కదా సార్, కే వస్తుంది అప్పుడు.
బాగా వస్తుంది. ఐ డాట్ జే డాట్ ప్రోడక్ట్ అంటే జీరో వస్తుంది.
డాట్ జీరో అవుతుంది సార్, డాట్ ప్రోడక్ట్ జీరో అవుతుంది.
అంటే ఏంటి, స్కేలార్ వస్తుంది నీకు ఇక్కడ. సో ఇక్కడ క్రాస్ ప్రోడక్ట్ అయితే నీకు వెక్టారే వస్తుంది, ఇక స్కేలార్ డాట్ ప్రోడక్ట్ అయితేనేమో నీకు స్కేలార్ వస్తుంది. స్కేలార్ అంటే ఏంటి, ఓన్లీ మ్యాగ్నిట్యూడ్,
ఓన్లీ మ్యాగ్నిట్యూడ్ ఉంటుంది సార్.
ఇక్కడ క్రాస్ ప్రోడక్ట్ తీసుకుంటే యు హావ్ ఎ మ్యాగ్నిట్యూడ్ యాజ్ వెల్ యాజ్
డైరెక్షన్ రెండు ఉంటే వెక్టార్ సార్.
సో దేర్ఫోర్ మూమెంట్ ఈజ్ నథింగ్ బట్ ఏ వెక్టార్ ప్రొడక్ట్ ఆఫ్ ఫోర్స్ అండ్ డిస్ప్లేస్మెంట్.
అవును సార్.
అంటే ఏంటి, అప్పుడు మూమెంట్ కి బోత్ మ్యాగ్నిట్యూడ్, డైరెక్షన్ రెండు ఉంటాయి. ఓకేనా?
అవును సార్.
నౌ యు టెల్ మీ, ఇన్ దిస్ కేస్ ద మూమెంట్ ఈజ్ అబౌట్ విచ్ యాక్సిస్? నౌ ఇట్లా నీకు చూపించాను నేను, ఇది x యాక్సిస్ అనుకుంటున్నా, ఇది ఆర్జెంట్ లో, ఇది y యాక్సిస్ అనుకుంటున్నా. ఇప్పుడు మూమెంట్ ఏ యాక్సిస్ లో ఉంది? If I draw movement something like this, about which axis this one?
Z సార్.
mz. సో z కాబట్టి దాన్ని మనం mz తో డినోట్ చేస్తాం, అంతేనా?
అంతే సార్.
ఇప్పుడు ఈ బోల్ట్ కి z యాక్సిస్ ఏమవుతుందో చెప్పు. బోల్ట్ లాంగిట్యూడల్ యాక్సిసా, లేకపోతే దానికి లాంగిట్యూడల్ యాక్సిస్ కి పర్పెండిక్యులర్ గా ఉంటుందా, ఎట్లా ఉంటుంది చెప్పు?
లాంగిట్యూడల్ సార్.
Longitudinal axis. So if you apply moment about its longitudinal axis, now bolt ఇలా ఉంది. If I apply, this is the longitudinal axis. If I apply the moment about this longitudinal axis, then what type of load will call it as? Bending moment or twisting moment?
Twisting moment.
Twisting moment sir.
అరే నేను వాడిని అడిగితే నువ్వు కూడా ఆన్సర్ చెప్పేంట్రా, నీకు కావాలంటే నీ క్వశ్చన్ నీకు ఉన్నాయి, నీ నంబర్ చెప్పి నీకు ఎప్పుడు కావాలని నేను అడుగుతా క్వశ్చన్. నేను అడిగింది వాడిని కదా. ఓకే, ఇట్ ఈస్ గోయింగ్ టు బి
ట్విస్టింగ్ సార్.
ఎప్పుడైనా మూమెంట్ అబౌట్ లాంగిట్యూడల్ యాక్సిస్ ఉంటే దట్ ఈస్ గోయింగ్ టు బి ట్విస్టింగ్ మూమెంట్. ఈ ప్రాబ్లమే కాదు, ఏ ప్రాబ్లం వల్ల అయినా లాంగిట్యూడల్ యాక్సిస్ కి మూమెంట్ అప్లై అబౌట్ దట్ యాక్సిస్, ఇఫ్ యూ అప్లై ఏ మూమెంట్, దాన్ని ట్విస్టింగ్ మూమెంట్ అంటాం. అట్లా కాకుండా లాంగిట్యూడల్ యాక్సిస్ కాకుండా లేటరల్ యాక్సిస్ అంటాం, అంటే ఈ లాంగిట్యూడల్ యాక్సిస్ కి పర్పెండిక్యులర్ డైరెక్షన్ లో. సో ఇది జెడ్ అనుకున్నాం కదా. ఇఫ్ యూ హ్యావ్ ఏ మూమెంట్ అబౌట్ ఎయిదర్ వై యాక్సిస్ ఆర్ అబౌట్ ఎక్స్ యాక్సిస్, దెన్ విల్ కాల్ ఇట్ యాజ్ ఏ బెండింగ్ మూమెంట్. సో లాంగిట్యూడల్ యాక్సిస్ కాకుండా అబౌట్ ఎనీ అదర్ యాక్సిస్. సో జెడ్ యాక్సిస్ లాంగిట్యూడల్ అనుకుంటే నువ్వు ఎక్స్ తో కానీ వై తో కానీ మూమెంట్ ఉంటే దట్ ఈస్ ఏ బెండింగ్ మూమెంట్. లాంగిట్యూడల్ యాక్సిస్ తోనే ఉంటే దట్ ఈస్ గోయింగ్ టు బి ట్విస్టింగ్ మూమెంట్. So now you tell me now. So twisting moment వల్ల ఏ స్ట్రెస్ వస్తుంది? నార్మల్ స్ట్రెస్ వస్తుందా, షియర్ స్ట్రెస్ వస్తుందా?
షియర్ సార్.
షియర్, రైట్. సో we'll call that one as torsional shear also. ట్విస్టింగ్ మూమెంట్ ఇంకో పేరు ఏంటంటే టార్షనల్ లోడ్, అంతేనా?
అవును సార్.
So because of that we'll have a torsional shear stress, right? Okay, so now follow the class. So that means this bending moment will create a torsional shear stress. So what I'll do is I'll take the torsional shear stress is due to a secondary shear force on the bolt. That secondary shear force will denote that one as, in the first bolt that is P1 double dash, in the second bolt it is P2 double dash, and third bolt it is P3 double dash, and fourth bolt it is P4 double dash. So that's what I showed it here. The moment P cross E about the center of gravity results in secondary shear forces P1 double dash, P2 double dash, and so on, so up to P4 double dash. Then if R1, R2, so here you can see the distance of each bolt from the center of gravity. This is the center of gravity of the bolt system. So now if I join center of gravity to the center of the first bolt, then the whatever distance between the center of the first bolt to the center of gravity, I'll denote that one as R1. Then center of gravity to center of the second bolt, we'll denote that one as R2. Center of the third bolt to center of gravity, the distance we'll take it as R3. Like that, the center of the bolt to center of the gravity, the distance between center of bolt to the center of gravity, we'll call it as Ri, where I is again 1 to n. If it is first 1, R1, 2, second bolt R2, third bolt R4, third bolt is R3, fourth bolt R4, like that, and so on. N number of bolts. If it is nth bolt, Rn. So like that, we'll take the distances. If R1 and R2 and so on are the radial distances of the bolt centers from the center of gravity. Then if I apply the moment equilibrium now, so movement due to the secondary shear force, that is in the first bolt it is P1 double dash, in the second bolt it is P2 double dash, in third bolt it is P3 double dash, in fourth bolt it is P4 double dash. So now suppose I want to calculate what is the moment of this P1 double dash. Again the formula is load into perpendicular distance. Here load is P1 double dash, perpendicular distance is R1. So the moment due to P1 double dash is P1 in P1 double dash into R1. Due to P2 double dash it is P2 into R2. For third bolt it is P3 double dash into R3. For fourth bolt it is P4 double dash into R4. But for equilibrium, the sum of moments created by the secondary shear forces should be equal to the applied moment. So applied moment is P into E or P cross E. So if you write the equilibrium equation, you are going to get this. That is P cross E is equal to P1 double dash into R1 plus P2 double dash into R2 plus P3 double dash into R3 plus P4 double dash into R4. But here in this equation, how many unknowns for you? P1 double dash, P2 double dash, P3 double dash, and P4 double dash is unknown. 4 unknowns are there. With single equation, you cannot solve for 4 unknowns. So then what I need to do is to simplify this one again. What we'll do is we'll make some more assumptions. What we'll do is we'll make some more assumption. Here one assumption what we made here is all the bolts are made of same cross-sectional area. So by making that assumption, we are able to find that the force in all the bolts is same. Primary shear force in all the bolts is same or equal. So likewise here also we'll make one assumption. That assumption is the magnitude of the secondary shear force is directly proportional to their radial distances from the center of gravity. That means this P1 double dash is proportional to R1, P2 double dash is proportional to R2, P3 double dash is proportional to R3, and P4 double dash is proportional to R4. Like that, whatever may be the secondary shear force is, it is directly proportional to the radial distances from the center of gravity. If you make that assumption, then you will get some more equations here. It is assumed that the secondary shear force at any bolt is proportional to its distance from the center of gravity. So then that proportionality constant will take it as some C. So that means, so with that assumption I can write P1 double dash is nothing but C1 R1. So where C is the proportionality constant. Like what I said is P1 double dash is proportional to R1. If I remove this proportionality symbol, if I want to write it as equation or equal to sign, I need to replace it by a constant here. So therefore, I can write P1 double dash as C1 R1, CR1, and similarly P2 double dash is CR2, P3 double dash is equal to CR3, and P4 double dash is equal to CR4. So that means now how many equations I have? This is one equation, second one, third one, and fourth one. Here 4 equations are there. In addition to these 4, you have earlier equation, that is the equilibrium equation. That means I have 5 equations. So now 5 equations, but how many unknowns are there? I have 5 unknowns. Here P1 double dash, P2 double dash, P3 double dash, P4 double dash. 4 unknowns plus this proportionality constant C is also unknown for us. So therefore 5 unknowns, 5 equations. I can easily solve these equations now. So now what to solve that, what I'll do is I'll substitute for what is P1 double dash. So P1 in P1 double dash. So here I'll replace this P1 double dash by CR1. In this P2 double dash I'll replace by CR2. P3 double dash by CR3. P4 double dash by CR4. Then what I'll get here? If I do that, C into R1 square. Then here I'll get C into R2 square. Here I'll get C into R3 square. Here I'll get C into R4 square. So throughout C is there. If I take C out, then what I'll get is C into R1 square plus R2 square plus R3 square plus R4 square. So from that, first I'll find the C value. So once I got the C value, I can find out P1 double dash, P2 double dash, P3 double dash, and P4 double dash, because we already know these radial distances R1, R2, R3, R4. We already know. C is the only unknown. So first I'll solve for the C. Once I solve for C, I can get these unknown forces also. That means here C is equal to P into E divided by R1 square plus R2 square plus R3 square plus R4 square plus so on. If you have 4 boards, it will stop at R4 only. If you have n number of boards, it will run for Rn square. So once you have C value, substitute back into this, you can get your primary forces also. So anyway, I think it is already now 10:15. I want to stop at this point. We'll continue this in the next class. So, okay, I'm closing the presentation now. Maybe we'll again discuss this in the coming class, next class, and then we'll close it there. We'll take up the numerical problem also. So then, okay, I think I already placed the attendance sheet in that classroom. Just respond to that attendance sheet and then you can leave the class.